Hello. Today we're going to demystify soil. So here goes for soil, quick and easy. So what is soil? Well, I've done a simplified diagram. It gives us an idea. And the part that really interests us is topsoil. That's the soil at the top, as the name suggests, where we plant our seeds and our flowers. Now, big plants like bushes and trees will push down from the topsoil through the subsoil and even down into the bedrock. But the layer that interests us is this layer, which can be anything from nothing to even a metre or 3 foot deep. Now, what is it made of? Here we have clay. I know it very well because my garden is full of it. Now, in winter, clay becomes waterlogged. And the problem is, if you have plants growing in clay, the roots will rot in this waterlogged soil. One way of testing if you've got clay soil is to take a lump of it, mix it with some water, and see if you can make sausage out of it. I call it the sausage test. It's the kind of thing we used to do when we were small children at school. We were always playing with clay, and that's a very good way of testing whether you have clay soil or not. If it's not clay, it won't stay together in one lump, it'll just fall apart. The other thing about clay is when it gets hot, like now in the summer, as you can hear, it becomes rock hard. And the problem with this is, if plants are growing in this, they have great difficulty in pushing their roots in this concrete-like substance. In fact, terracotta, like here, is from clay. Terracotta means literally baked earth, baked clay, in fact. So, clay on its own is not so great, but it's a constituent of our soil. Clay, when baked hard, becomes almost impermeable. So as we can see here, pouring water onto the clay just means that the water runs off. It's not being absorbed and being supplied to your plants, which are in desperate need of water in the summer months. So in clay soil, plants can suffer from dehydration. The next constituent is sand. Now, unlike clay, sand doesn't waterlog in the winter in general. It allows water to pass through very easily, which means that your plants don't get waterlogged and so the roots don't rot during the rainy months. The disadvantage is simply in the summer, when it rains, again, the water will pass through the soil very quickly and your plants may not get enough water to continue their growth in the summer and actually suffer from dehydration. Also, because this soil is very what we call friable or crumbly, certain root vegetables can grow in it very easily, things like carrots, because they can push their way through the soil without too much resistance, unlike in clay, which turns into a concrete-like substance in the summer, as we've seen. Now, between sand and clay, we have a thing called silt. Now, silt is laid down by rivers. It's normally deposited on floodplains. In fact, the ancient Egyptians profited very well from this deposit of silt in the Nile Valley and had a very, very healthy agricultural system going thanks to this silt. Now, the difference simply is grain size. We have big grains in sand, small grains with clay, and in between the two we have silt. And these are the three main constituents of soil. But there's one big thing missing here. So let's have a look at what nature does to make soil. I'm in a small wood, a little bit of forest near where I live. This is the perfect place to show how nature produces soil. Now, in an environment like this, in a forest, leaves, branches, even trees fall to the ground, mixed up with dead insects and dead animals. On the ground, they are decomposed by a whole ecosystem of microorganisms, such as bacteria or funguses, or even very small invertebrates and insects. We can think of, for example, earthworms. And what they produce is this. This is what we call a humus or organic material filled material which we can grow in. It's a mixture of, as I said, the breakdown products plus the soil that was here originally, and it produces this fantastic growing medium. The growing medium that we call soil. So, to produce the perfect soil, we need organic matter or humus. Now, if you put humus in your soil, any soil, it will improve it. Humus is things like compost or even manure, well-rotted manure that is. You put it in sandy soil and the sandy soil will not only be full of nutrition, but it will also retain water better so your plants don't dehydrate during the hotter months. And if you put compost or well-rotted manure into your clay soil, that will actually help drainage and stop your plants drowning and the roots rotting in the winter, and of course will bring more nutrition too. Now, one thing we haven't talked about is pH, or acidity of the soil. Now, before you panic, I know we're not going to do a chemistry lesson. We as gardeners need to know a few fundamentals, but not everything there is to know about acidity. So, what is acidity of the soil, or pH? Well, there's a scale called the pH scale, which goes from 0 to 14. In the middle of this scale, we have what is called neutral, and at the lower end of the scale, we have acid. So 0 through to 6, and just up to 7 is acid. So we have things like vinegar and lemon juice, for example, which are acid. And then after 7, from 8 through to 14, we have alkaline, things like bleach. Now, we don't really care about most of this stuff, apart from the fact that soil can be slightly acid or slightly alkaline. And there are certain plants, particularly certain what we call acidophile or acid-loving plants, which will not be able to grow in an alkaline soil. Now, what causes an alkaline soil? Most soils are kind of slightly acid, but if you live in a limestone or chalk area, that will actually change the acidity of the soil, and it may well become alkaline. Now, how do we know? Well, simply, you can buy a little kit from your garden centre, follow the instructions on the box, and you can test the acidity of the soil in your garden. I would recommend checking a number of different parts of your garden, because the acidity can change, and you could actually have parts that are very acid and parts that are very alkaline, depending on what's underneath the soil. So, what plants won't live in an alkaline environment? Well, there's certain common plants like rhododendrons and azaleas, or camellias, or various other plants which will not be able to thrive or even survive in alkaline soils. They'll actually die. Another example is the Acer, or the Japanese maple, which is an extremely popular plant. So that you don't waste your time, effort and money buying plants that will ultimately die in your soil, I suggest you do a test to ensure that you know whether your soil is acid or alkaline. And if you want to grow a plant that will not thrive in your soil, put it in a container and fill the container with the right kind of soil. For example, for acid loving plants, you would put in ericaceous soil, which is basically acidic soil. So there we are. We've done the tour. Soil is not that complicated after all. We now know almost everything we need to know about soil. We know its constituents, which is clay, silt and sand. And of course, the important thing, which is the organic matter. The organic matter brings nutrition, structure, and a whole army of microfauna and flora. We can improve our clay soil by adding organic material such as compost or well-rotted manure, but there are plenty of other sources of organic material. In clay soil, it will stop clay being waterlogged in the winter and stop it turning into a concrete-like substance in the summer. And in our sandy soil, it will help to retain a certain amount of water for our plants, which are very thirsty in the summer. Now, apart from all the things we've talked about when we talk about organic material, another thing I haven't mentioned is air. Now, plants actually need air around their roots. Not a lot, but little air pockets certainly add to the health of your plants, and they need that. And the organic matter will, by itself, structurally provide little air pockets, but also a lot of the little organisms that come with it will burrow into the soil, leaving little burrows and galleries, which will again aerate the soil. We've looked at pH, acidity, so now we know we can get a little test from the garden centre to test our garden to see whether it's slightly acid, neutral or slightly alkaline. And there are certain plants which are a bit fussy about whether they grow in acid or alkaline soil. So we can check on the label or ask the garden centre staff, or even look on the internet or in books to find out if it's one of those choosy plants. So we don't waste our time, effort and money putting the wrong plants in the wrong places. And of course, we always have our solution of putting them in containers if they're not going to be happy with the soil that we have. So there we are. We have talked about everything we really need to know about soil. So, over to you. Happy gardening.